how this will work is through, as I mentioned earlier, linear referencing um, fundamentals, if you will. So these 1D objects, if you will, have traditionally been referred to as events that occur that can exist as point events or linear events. Point events are located by a specific distance measured along a specific roadway. Linear events are identified by a starting distance and an ending distance, start and end measure, if you will, on a specified roadway. So linear events can also be specified using a starting measure and a length, if you will. And the sum of these two values determine then the ending measure. So um, another utility of using GIS transportation or GIST is the ability to take data presented in 2D and 3D coordinate systems and collapse them into one dimension. For example, to convert them into point and linear events based on how they interact with the roadway center lines. For example, signs and crash locations can be treated as point events, if you will, that can be associated with surface types, pavement conditions, lane width, which is we're getting into the geometry and the cross section of the roadway, traffic volumes, all can do all of which are all of these are linear events, but we can do multiple of those. So maybe longitudinal geometry of the road and so on and so forth. So as we know, there are issues with not using the LRM, um, but the systems are intended to address these four fundamental issues, if you will. So the first one is transportation facilities are not discrete, meaning one can walk outside and readily identify a roadway, for example, but what are the physical limits of that roadway? More importantly, perhaps, what is the identification of that roadway? Is it defined by the name or some other characteristic? And so on and so forth. This example demonstrates that there is no single way to segment transportation facilities when designing a database for multiple user groups. So the second one is transportation facilities change frequently. This is a big issue, and a single attribute at one location may not change for years. However, given the spatial extent of a state roadway system, an attribute is changing somewhere every day. So editing the database to keep it updated it'll be a very tedious task. And so if an agency uses the block segments approach and a street is repaved for a distance of say 2 miles, there may be a dozen of block segments that now need a new entry for the last paved date. So not only is there a physical process of entering the new data, there's also the problem of getting the new data to the editors. So we can hire someone to enter this data, the new data that is constantly changing, but we also need to getting that new data to the editors. So someone has to be given the task of telling the editor that was what was changed and how it was changed, and then when the change took effect, and the editor has to provide the updated information to all of the users that are using. So that's a big, the second one, it's a big issue that that if using the LRM, we'll see later, will solve it in a way that issue. The third issue is many attributes are continuously variable. For instance, in speed limit, jurisdiction, functional classifications, and many other attributes, there cannot be any gaps. Every piece of each roadway must have one and only one value of these attributes. So that's another issue. And the fourth issue is attributes do not always change at the end of the segment. Some attributes do not apply to a whole segment. A 500-foot long block might have 30-foot loading zone designated along the segment length. The parking enforcement and traffic operations divisions will need to know that it exists and where it is located. So roadway elements such as signs are point entities that may also need to be included. How can be that done with segment-related design? So segment-related design shown in the first, and the linear referencing model data shown in the second example. You can see that in these two we have repeatable data. So in the first one we have 25 miles, 25 miles. We have city, city, county, county. We have asphalt for all of them. We have 3 5s for functional class. And when you look at LRM data, you can see that there is no repetition. So the 25 and 25 are essentially combined. The 5s are combined. The asphalt, it's along the whole segment, and we have the length of the segment as a whole. And then each address range, if you will, based on the segment data ranges that were specified previously.